most people are aware of what I call periodic cataclysms that strike the planet. One of the things that people should know, and I get into a little astrophysics now, is that our star system is a trinary star system. Most in the galaxy are binary or trinary. Over 73% of them are at least binary, and a good percentage, around 15 to 18%, are trinary. It's very rare to see a star that actually doesn't have a partner. And the kind of partners you have is you have usually a failed star we call a brown dwarf or a red dwarf. A red dwarf star, because it burns its fuel very slowly. Our star, which is a yellow dwarf, is likely to go for at least another 5 to 10 billion years. But the red dwarf stars can go, because of the rate that they burn fuel, for 100 trillion years. And they have a magnetic field 100 times to 200 times stronger than our planet, our sun, even though they may be only 10 to 20% of the mass. Their temperature is only about 5 degrees above absolute zero, but they have a magnetic field 200 times stronger. And when the folds of the magnetic field flip and cross, which causes a coronal mass ejection, you can get a CME, or coronal mass ejection, or a solar storm. The storms that occurred on red dwarfs are actually hundreds or even thousands of times more energetic. And the flux fields of their magnetic field are so strong they can affect planets and stars up to a light year or more away. So they affect things like the Higgs field, which is the gravitonic, not the gravitonic field, but what's called the embedded space-time field. So they can alter plate tectonics in planets that have plate tectonics. They can cause stars to get more active. They can cause unusual things to occur on distant objects throughout the solar system. And we have an object that has been previously named the Destroyer, Herculebus. Some people call it Nibiru, but it's not a planet, it's a star, and it does have orbiting objects around it. If you actually look at the history, the object that returns to our solar system about every 3,650 years is a red dwarf. Red dwarfs are really common in our galaxy.
Dangerous to us?
Very dangerous. And what happens is when the red dwarf returns, there's really good evidence that we had, if you look at Velikovsky's research, because it's strong magnetic fields. Tell him who
Immanuel Velikovsky, a visionary who wrote in the 50s and 60s about a solar system that we live in movement, under electromagnetic flux. It's an electric universe, basically. It's what the Thunderbolts people are pushing. And that's what Velikovsky pushed.
He had enough respect from Albert Einstein. They were good friends. So he wasn't just like a...
Yeah. No, he wasn't a flake.
Just a fruitful guy, let's put it that way.
Yeah.
And he theorized that these red dwarf stars would carry iron ore dust and in their tail and also in their corona. In other words, a big bubble around the head of the red dwarf that could be quite expansive. And because you can't see these, you can only see them with an X-ray telescope or infrared telescope like IRAS, infrared telescopes, or SOHO.
Is that why the Vatican built the world's largest infrared scope in Arizona?
Yeah, they're
looking for something.
Also in Antarctica, the McMurdo base, because I actually took care of people going back and forth for a year and a half that were actually going to McMurdo to our SPT and classified projects. Right? So the SPT we have what's called a pi meson scope that's below the ice field. And what they would do is call pi meson sensors that are up to 3/4 of a mile under the ice shelf. And those pi mesons, basically, they pick up and build up a picture of the galaxy based on the pi mesons, because pi mesons will go to the planet or stars or anything, and basically nothing stops them. And they have what's called pi meson detectors. The other thing is that they have all kinds of different scopes. For example, about 4 years ago, a German Zeiss-based infrared telescope was put on a US 747. So they have this flying US 747 that go 50,000 feet up as high as one of these can go. And they can image basically almost as good in far infrared as the Hubble telescope could do in the visual. And they were looking very much for the perturbations of the planets Uranus and Neptune since Tycho Brahe, the Danish astronomer, discovered this over 100 years ago. And all of the theoretical physicists know that there's large objects now. The reason to discover what's called a super-Earth, estimated in the Oort cloud, about 0.73 light years to be about 10 times the size of Earth out there. And they found Sedna and other planetoid-like objects. That's why they demoted Pluto.
Uh-huh.
The fact is, though, there's an object in deep space that's just above absolute zero, and it's probably a red dwarf, and it's probably pushing comets into our inner solar system.
Well, now, am I right? When they recently came up with the object that was bigger than Pluto, further out,
that's right.
Its orbit suggested what you're talking about. There's no proof of it, but it suggested it because of the mechanics.
Because of the gravitonic effect and the space-time
Yeah,
effects.
the orbital mechanics. I got you.
Right, and the first time the perturbations are picked up was by this Danish astronomer. So putting it all together, including my classified sources, we are visited by an object that's called a destroyer. It's called the Dragon Star. It's called Herculebus. There's dozens of names. Almost every people on Earth have a name for it. And when it comes into the solar system, you don't see it until it comes near the sun, and then you see wings of fire, plasma, that reach off it from this basically dark star, if you want to call it dark star. And it causes major super solar storms on the sun, which trigger off earthquakes, volcanoes. As it comes into the solar system, whether it's the corona or the tail, whether it's on its entry phase or exit phase, it has a tail of iron ore, which Velikovsky predicted, and which fits in also with the story that I spent an entire evening with Dr. Isley, the PhD physicist, owner of Vitamin Cottage and founder of the World Constitution Parliament Association under the United Nations. And their idea was to put iron ore to capture carbon dioxide and have it go to the ocean floor. What they discovered, iron ore caused a massive bloom of algae. When the algae then bloomed, they would then die and go to the bottom of the ocean floor and carry the CO2 with their dead bodies. So what we're seeing all around the world, and you can Google this, is the number of rivers, streams, like the Jiangong section of the Yellow River, Yangtze, Switzerland, all over the world you'll see questions. All of a sudden, these rivers and areas become red. And then, of course, they talk about an algae bloom. So this is totally separate from Fukushima. What it means, basically, is these are warning signs that a period of rapidly increasing dangerous coronal mass ejections and earthquakes is coming. I can't
all right. Hold it
whether
right
it's
there.
Years or decades.
Yeah.
But these,
hold on.
these
Bill,
warnings.
hold on. We'll come back, and I want you to just rewind a little bit. We'll revisit that in just a minute. Got to take our break. Be right back with Dr. Bill. Hang on. Okay, talking with Dr. Bill. All right, Bill, if you can back that up just a little bit and carry on with your conversation.
I'll roll it back a bit. If you look at just Google the term rivers turning red.
Okay, sure.
Look at, for example,
history is full of legends about this. Yeah, okay.
Yeah, they just put it up on your Google or search engine. What you'll discover is there's a lot of rivers turning red, and some of them will claim that it happened because somebody dumped something, like in Beirut. They thought they dumped some kind of a toxic red chemical. They're surprised in Britain, or they off the beaches in Sydney, Australia, where they think it's a red tide. The fact is that this is very typical. If you put water and you add iron to it and have sunlight, it's going to give you a red hue. As you get a massive bloom and then you get a dinoflagellate bloom afterward, and you end up with a red tide. And that's also part of the reason why you're going to get an increase on its own of domoic acid, because there's a release of iron that occurs periodically that can be a factor causing a red tide. They happen in the Red Sea. This is one of the reasons why it's prescribed against eating shellfish, because they concentrate domoic acid. Mm-hmm. And when you add other radiotoxins, they actually speed this process up. So if you have cesium in the background, it increases it quite a bit. It's cesium-137, just like that growth factor. So, for example, it's an analog of potassium magnesium. So if you get cesium-137, we're already having 10 and 12-year-olds in Fukushima Prefecture going back home, and they're having cardiac arrhythmias and heart failure. So the reason why I mention this about the red is it actually goes right back to the Bible. And if you research the astrobiology and the astrophysics of what's happening here, what happened is 3,600 years ago in the Eastern Mediterranean, it was the last remnants of the Atlantean Empire in the Minoans. And they were the most advanced. They had flush toilets. They had all kinds of technology. And what happened is the island of Thera blew up. It was a volcanic island. And it was the debris from that island that landed on Egypt and on the areas of the Second Empire, the Second Kingdom of the Egyptians. Beforehand, of course, the Nile River turned red, which is an algae bloom. And it all fits that. What we're seeing here is things like telluric currents, which occur in the ground, mm-hmm. which drive frogs out and animals out of the ground. Because when you're getting a large magnetic object passing the Earth, you're going to have these weird things like things that are in the ground are driven out by very powerful ground currents called telluric currents.
Yeah.
So what I think we're facing here is we've had a massive increase in earthquakes, and we're also having a lot of sinkholes all over the world. We're having release of methane hydrates that are also being released from deep in the ground, including high levels of radon. And a lot of these things are happening spontaneously because the Earth is being magnetically operated at a great distance by this object. And I think what we're going to have is massive increases in earthquakes, which means we don't have a lot of time to remediate these plants so they won't break down and cause many Fukushimas.
Even if we started tomorrow, we don't have enough time. There's so much work to be done.
I don't know when it'll happen. The thing is, all we're saying here is that these signs are equivalent. It appears that we are probably reaching that time period around 3,650 years, roughly, where this object returns to the solar system. And if you actually look at the historical record, it may not do it the first time, might be in multiples of it the second or third time, but it might also fit in with the Younger Dryas period, which is between 11,000 and 12,000 years ago, where we had 1,000 years of darkness. We had another, if you want to call it, relapse into the Ice Age that was present before that, called the Younger Dryas period. And of course, that period of Ice Age also occurred around 13,000 years ago when we had a nuclear war with remnants of those nuclei present in Saudi Arabia, Yemen, and northwestern India, which is near and they were actually near Bombay, India. So these things have been well investigated by chemists that are not religious, and they proved those nuclei couldn't be formed by an impact from an asteroid or comet or any other space object. They were created by a nuclear explosion on the ground. And there's also remnants of certain isotopes that could only occur in a nuclear war. Xenon-129, I think, is one of them. So what I think we're facing is we're going to have increasing cataclysms of global climate acceleration, of bad weather, of ozone hole deterioration, which is amplified by not only the radioiodine, but also other gases. And it's also aggravated by massive fluctuations in the magnetic flux field of the Earth. Because the Earth field has been decreasing for thousands of years. And when there's an external field affecting that, and the world's oxygen concentration is relatively dropping because the number of dead zones in the oceans are increasing, like the Gulf of Mexico, after the drilling at the Macondo drill site, we now have the invasion of Australian jellies because they don't need oxygen, because a lot of the Gulf of Mexico is basically a dead zone. There's very low oxygen in great parts of the Gulf of Mexico now. There's, I think, around 10,000 zones, some of them up to 200,000 or 300,000 square miles of the oceans around the world that are dead now, basically hypooxygenated.
Gone.
They're gone. And we have a giant ozone hole, magnetosphere hole in the South Atlantic that you have to fly around or knock out your communications and your ability to your avionics, which the Russians discovered when they were doing some contract work down in the area. They were actually going to do some weather modification for the Brazilians near Sao Paulo to push some cyclones out. And there were some flights that had some serious disruption. NASA, I think 5 years ago, put 5 satellites up in the upper, inside the third belt of the Van Allen radiation belt, about 20,000 miles out. And they discovered that magnetosphere hole was 5 times the diameter of the Earth at that distance. So there's a lot of things happening in space weather that are anomalous, but when you take into account Velikovsky's theories and the presence of iron ore in these red tides and the wisps, even when the Halley's Comet went over, there are specific molecules that are present in the tail of Halley's Comet, and those are virtually identical to some very simple forms of nerve gas.
Remember, it's Halley's Comet. Remember,
Halley's Comet. So in other words, Halley's Comet has in its tail toxic chemicals that can actually affect animals and humans in terms of their behavior, and has a potential if the concentrations are high enough to kill.
Now that's very interesting. I have not heard that before.
Right. We have this from my chemist friends and others that have actually shown that Halley's does have the potential, depending on how deep we pass through the tail of it. So we can think of the Earth as a closed loop. The plasma of the Earth's ionosphere is directly connected to space weather, and space weather is affected by these objects, like these highly magnetic objects, the red dwarf stars, and by comets that also can, perturb the magnetosphere of the Earth and cause earthquakes and volcanoes. Now, if you take on Earth, we are dependent on technology like nuclear reactors that we wrote a sharp pencil to say
we're really not.
It's very rare to see a star that actually doesn't have a partner. And the kind of partners you have is you have usually a failed star we call a brown dwarf or a red dwarf. A red dwarf star, because it burns its fuel very slowly. Our star, which is a yellow dwarf, is likely to go for at least another 5 to 10 billion years. But the red dwarf stars can go, because of the rate that they burn fuel, embedded a space-time field, so they can alter plate tectonics on planets that have plate tectonics. They can cause stars to get more active. They can cause unusual things to occur on distant objects throughout the solar system. And we have an object that has been previously named the Destroyer, Herculebus. Some people call it Nibiru, but it's not a planet, it's a star, and it does have orbit for 100 trillion years. And they have a magnetic field 100 times to 200 times stronger than our planet, our sun. Even though they may be only 10 to 20% of the mass, their temperature is only about 5 degrees above absolute zero, but they have a magnetic field 200 times stronger. And when the folds of the magnetic field flip and cross, which causes a coronal mass ejection, you get a CME, or coronal mass ejection, or a solar storm. The storms that occurred on red dwarfs are actually hundreds or even thousands of times more energetic. And the flux fields of their magnetic field are so strong they can affect planets and stars up to a light year or more away. So they affect things like the Higgs field, which is the gravitonic, not the gravitonic field, but what's called the. Most people are aware of what are called periodic cataclysms that strike the planet. One of the things that people should know, and I get into a little astrophysics now, is that our star system is a trinary star system. Most in the galaxy are binary or trinary. Over 73% of them are at least binary, and a good percentage, around 15 to 18%, are trinary.